Okay, so our first word is going to be point. Already messed it up. First word is going to be point. So you'll notice in your learning goal, it said we are defining undefined terms, which kind of sounds weird, right? How do you define something that's undefined? Along the edge of that first page, I'm going to have you write undefined terms. Okay, so our undefined terms are points, lines, and planes. Like our basic like unit in geometry is a point. So anyone taken chemistry before? We're in chemistry right now. Yeah? You guys know like the basic or the smallest unit in chemistry? Yeah, I saw you say it. An atom, right? So this is kind of like our atom. This is like our first building block. They build on each other. So a point builds to make a line, lines build to make a plane. So these are like our most important, our basic terms in geometry. They are called undefined because we don't measure them. So there's no way to measure a line because it goes on where? Forever, right? So a point, I think of a point kind of like you're dropping a pin to your friend to tell them to come to your other friend's house, right? What are you sharing with them when you drop a pin? A location. So that is what a point is. I'm going to use some different colors, and again, if you want a ruler, they're in the back. You don't need a ruler for a point. Okay, so it's a location in space, but we're not going to write that. A location in space with an indefinite, or I'm going to not write that word. I'm just going to say with no shape or size. So today's, or my undefined terms are super spatial, super visual kind of terms. So we cannot measure a location. It is just showing us where something is located. All right, if I asked you to draw a point, what would you do? Draw a dot. That's what we're going to do. So that is a point. Simple as that. Okay, but we have to name all of our points, lines, and planes. So again, we start with points. So to name them, you either see it with just an uppercase letter. So sometimes you'll see it just with like a capital A. That represents point A when we're naming it or talking about it. Sometimes you'll see it written with the word point A, and then other times you'll see it like that. Okay, most of the time in our illustrations, or all the time, you're going to see it with a point or a dot and then the name right next to it. So if you see an uppercase letter, that means that we have a point. Okay, we'll see some cursive letters in a second. That's not a point. All right, next to point, I'm going to put a 1 because that is like my smallest unit. It just takes 1 point to be a point. Okay, I'm going to put a big 2 next to our next word, which is a line. Maybe. Okay, so it takes 1 point to be a point. It takes 2 points to be a line. So this is made up of 2 points, 2 or more points, but it has to be at least 2. Okay, and what did we say a line does? It goes on where? Forever and ever. What's a better word for forever and ever? Infinity, yeah. So, or infinitely, that's our better math term. Okay, so it's made up of 2 points. It has no width, so we're not measuring it, and it extends infinitely. It extends infinitely. So we're going to draw an illustration first. If you want to use your ruler, now would be the time to do that. So I'm going to pick 3 points for this one, just to make it a little bit more complex. So there's my line. I have 2 arrows. What do the arrows signify there? Good. Infinity. Okay, and we have 3 what on here? What do we call these things that I just drew on my line?
Points.
Points, right? So what do we have to do? How do I name those points? What do they need? They need an uppercase letter. So, MJ, give me 3 uppercase letters, please. Or 3 letters.
A, M, and B.
A, M, and B. Thank you. Okay, so we said it takes how many points to become a line? 2. So remember, that's like our number to keep up with here. So 1 goes with 0.2 is our number to remember for a line. So to name it, we only need 2 points. But I have in my picture how many points? 3. So I want you to pick 2 of those letters and write them down, please, where it says name and notation. It does not matter which 2 you pick. So any 2 letters that are there, and they have to be written capitalized. Okay, and I see some of us, that's fine if you just wrote them anyway, but we're going to write them, you can just write it straight underneath. So I'm going to pick AB, and I'm going to write them just like that. So we don't need the point symbol anymore, we're just writing AB. Did anyone pick another set of points? What's another combination I could have done here? And what?
M and B.
There's no W.
MB.
MB. What was another one that could have worked?
BA.
AM. Is that what you said? I feel like someone just said E.
Someone said BA.
Okay, BA works, AM works, MB works. All of these combinations are fine. The only thing extra that we need, and I'll write some other examples here. So AM, MB, all of those work, but in order to become a line, we have to draw the line symbol up above. So you have to have a dash with the 2 arrows. So just a little line symbol up above. Okay, so that is how we're going to name a line with 2 points there. The other way to name a line, which I think is easier if it's an option, sometimes you'll see a lowercase cursive letter there. So what lowercase cursive letter did I write? An L. So this can also be written as line L with a lowercase cursive letter. That is not always an option, but if you do see a lowercase letter there, you can use it to name it. So that takes a little bit less effort. Okay, so 2 points make up a line. Okay, and then our last undefined term. So again, they're called undefined because they cannot be measured. Our last one is plane. And I'm going to write a big 3 out to the side. So how many points do you think it takes to make a plane? Good, 3 or more. I like that someone said that. So this is a flat surface made up of 3 or more points and extends infinitely in all directions. In all directions. Okay, so to draw it, it actually is just a parallelogram. That's kind of like the generic picture or illustration of a plane. So make it as big as you can because we're going to need the space. But a parallelogram is basically just a slanted rectangle. I'm not an artist. You'll see that. I should make it a little better, but it's fine. So make it pretty big because we're going to put a lot of things on it. Alright, so I know I need at least how many points on here? We need at least how many?
3.
3, right? 3 or more. So it has to have at least 3. So I'm going to put 3 in a line And then I'm going to add a fourth one over here, just to make it a little bit more complicated because we are ready to use our brains. Okay, so make sure 3 of them are in a line, and then just do one extra one. Okay, TJ, can you pick me 4 letters, please?
D, Z, Y, L.
D, Z, Y, and L. Okay, thank you. So I'll give you a second. D, Z, Y, and L. Okay, so to name a plane, you always have to start with the word plane. So we know we're going to be saying plane something. And how many points do you think it takes to name a plane? 3. Okay, that's why I wrote a really big 1, 2, and 3 there. We name a line with how many points? We name, listen to what I'm saying. We name a line with how many points? 2. We name a plane with 3. Okay, so that does get a little confusing, but we're going to practice that today. So we have to pick 3 points. I'm going to give you another vocab word here. They cannot be what's called collinear, which means they cannot be on the same line. Okay, so when I'm picking my 3 points, I cannot pick the ones that are on the same line. So what 3 points can I not use here, Sadie? What? Yes. What 3 points can you not use here? Good, D, Z, and Y. So we have to pick some other combination here. So what point do we have to add in? L. So can I do L, D, Z? Are those 3 points on the same line? No, they're not. So that would work. I could do D, Z, L. Okay, with your partner, I want you to figure out another combination. So I'll give you a second and I'll pause the video here. So L, Y, Z is another combination that would work. Anyone want to test theirs, make sure we're good, Jackson?
L, Y, D.
L, Y, D, yep, those work. So any other combination there works. The easiest way, kind of like a line, sometimes you'll see a cursive letter in the corner. I'm going to pick M. So if you see a uppercase cursive letter, we can name it plain with whatever letter that is. So I could also name this plain M. It has to be uppercase and it has to be cursive, so I'll write that underneath. Has to be uppercase and cursive. How do I know that this is not a point? Because a lot of people get confused and say that's a point.
It's uppercase.
It's uppercase and I heard someone else. There's no dot, there's no point. So make sure you're paying attention to that. Okay, I'm going to make a little note off to the side. So my points cannot be collinear, and we're going to write down that definition right now. What did I say that means, collinear? Just points on the same line, that's all there is to it. So flip to your next vocab sheet. Don't put them in your rings yet, because we're going to need them for the note, for the next note. Alright, I'm going to move a little quicker now. So, collinear, what did I say that means? Points where? On the same line.
I didn't get 3.
Points on the same line. That is all there is to it there. Okay, so in my picture here, I'll give you a second to write that down. So just 3 points ABC, and then I put another point just kind of out there in space. Okay, so in this picture, I want you to turn to your partner and talk about which ones are collinear. I'll give you like 10 seconds. What points are collinear here? Good, so what are my collinear points? A, B, and C, and I'm just going to put little commas in between. Okay, underneath I'm going to write the word non-collinear. What do you think non-collinear means? Good, you guys are smart. Non-collinear just means the opposite, so points not on the same line. So turn to your partner, pick 3 points that would be non-collinear. Hey, Holly, what did you guys say up here? D-A-B. Good, so those would be considered non-collinear because they're not on the same line. So pretty simple there. Okay, then we have our next word, which is coplanar. If collinear means on the same line, what do we think coplanar means? On the same plane, awesome. So points on the same plane. Okay, I'm going to draw 2 planes that are not intersecting. I'm trying to draw a picture of what I call parallel planes. Anyone remember that word from algebra? Parallel just means what?
Same.
They do have the same slope.
They don't ever like cross.
They don't ever cross. What's a better word for cross in math?
Intersect.
Intersect. So they are never intersecting there. Can anyone tell me where parallel planes are in this room? Raise your hand, please, if you think you know where a set of parallel planes are in this room. Someone else? Someone else? Eiley?
The front of the room and the back of the room.
Yeah, so like the front wall and the back wall, right? If those continued on forever and ever in space, would they ever touch each other? No. Where else are they? Someone else say something. Just real, you don't have to raise your hand, just call it out.
The roof and the floor.
Yeah, the ceiling and the floor. So you can think about that in terms of planes. It's any flat surface, so your desk would also be a plane. Okay, so I'm also going to draw, we're going to get a little crafty here. We're going to draw a line crossing through those parallel planes. So you have to think a little bit visually, a little bit 3D. So it's pushing through kind of like a piece of paper. I'm going to skip over because we can't see underneath that paper. And then it's going to come down here and push through that piece of paper. So it should look something like that. And then you can add some dotted lines underneath if you want. So anytime you see dotted lines, that just means from our view, we can't see through that paper. Okay. Very good. We're going to add some points to that, and then I'll let you guys try it. So I'm going to do A, M, and G on my top plane. And then on the bottom one, I'm just going to do X, Y, Z. Okay, so with your partner, after you have those points down, go ahead and turn to your partner, pick 3 points that are coplanar. 3 points that are coplanar. Okay, so write down your 3 coplanar points. Navi and Mandy, what'd you guys pick? AMG works. Okay, turn to your partner, pick 3 points that are non-coplanar. 3 points that are non-coplanar. Okay, Chantel, what did you guys pick? And Jasmine? XMG. Do we agree? XMG, does that work? Yep, that works. Okay, here's a little, you have to think while I'm saying these words. What are 2 points that are non-coplanar but are collinear? There's only one answer here, see if you can find that. Don't say it out loud.
You said what?
So find the 2 points that are non-coplanar but are collinear. Just think it to yourself. When you know the answer, raise your hand. Non-coplanar but are collinear. Derek,
M and Y.
what'd you say?
M and Y.
Good. M and Y would be the ones that are on the same line but are not on the same plane. Questions with coplanar, collinear? They're just fancy words. Okay, 2 more vocab and then promise we'll stop with the vocab. Okay, line segment, and I'm gonna go even faster now. Line segment would just be what of a line?
Part of it.
Yeah, a segment of a line. Yes, a part of the line, thank you. So a part of a line. What's the difference between a line and a line segment? Other than it being a piece of it.
The line has arrows, line segment has points.
Okay, I heard lines have arrows and line segments would have points. Very good. So a part of a line with 2 endpoints and all points in between. And I'm just doing some shorthand notes here, so I just abbreviated points and abbreviated between. Okay, so it has a start and a stop. That's the only difference here. So I'm going to go ahead and draw my line segment
All points
in between. Okay, so what are my only 2 options to name this line segment? GM or MG. Good. Sorry, that's a G. GM or MG. You guys read my handwriting so far? Okay, if I added a 3rd point here, would that still work? GM or MG if I wanted to name the whole segment?
Yes.
Yeah, because I only need how many points to name a line or a line segment? 2, very good. So from the start to the end. Okay, last one is called a ray. And you should have heard of that. Yes, have we heard that word before? Array? No? So I think of like a ray of sunshine. Where is a ray of sunshine starting? At the sun, and it's going towards us, the earth, right? It's not traveling backwards, it's just going in how many directions? Just one direction. So this is a part of a line with 1 endpoint. With 1 endpoint. And extends infinitely in one direction. Okay, I promise this is a lot more vocab than we usually have, but we're just learning the beginning stuff. Okay, so it sounds just like it, or it looks just like it sounds. So we have 1 endpoint, and it is traveling in one direction, so it looks like a what? Just looks like an arrow. So that's our symbol for array, it's just an arrow. So I'm going to pick 2 points. I'm going to do R and S. This does have a direction, so we always have to start at the end point. So what's my end point here? R, very good. There's no arrow, so I'm going to start at R, and then it travels through S. So I would name this ray RS with a little arrow up above it. So it has a direction, and we can't flip-flop that. Okay, questions? We're going to practice a little bit, so flip to your lesson page that I passed out. And I believe in you guys, so I'm going to pause the video here and walk around to help you guys. But go ahead and work through the first one. The only one I think you're going to need help with is the last one, E. Okay, so I'll pause it here. Go ahead and try that whole number 1. Okay, so the intersection of 2 lines, if you think about where 2 lines are intersecting, they intersect at a what?
At a point.
At a point. Good. So I'm going to write that directly underneath. So 2 lines intersect at a point. So So it asked you for the intersection of lines P and R. So where was that point of intersection? Point N. And I think everybody got that, so very good. Okay, we're gonna skip a few here. So we're gonna skip that one and that one. I would like you to do C and D and E with your partner, please. C, D, and E. Okay, so you have to have the word plane written here. What was my easiest name? Plane M. How do I know that is not a point, but the name of the plane? Uppercase, cursive, and no point. Very good. If you did another type of name, it would be plane with how many letters? 3. What could those letters not have been? Raise your hand, please. What are the only letters that could not have been? K. Good. Any line or any points that are on the same line, so we could not have used D, E, F, but I saw lots of people doing A, D, E, which is a good example. And that helps us out with our next one. An example of 3 non-collinear points would also be A, D, E. It could also be B, F, E. It could also be C, D, E. Lots of different options there, as long as they're not on the same line. Okay, and then the intersection of plane M and line K. This is like if you have a piece of paper and I push the pencil through it, that's going to intersect at a what? What were we looking for there? A point, good. So what was the point where this line K pushed through the paper? E, very good.
Yes.
Okay, and the last one, we're going to move through it even quicker. The intersections of line L and M. We said 2 lines intersect at a point. So let's look for that.
Where's the L?
L is here, and M is here. So where did those 2 lines intersect, Michael? E, very good. Okay, I'll give you a second to pick 3 points for the next one.
Where's Q?
Q is the name, that's a cursive Q.
Oh, mine looks like a 2. Like, mine looks different from yours.
Oh. It's just a cursive Q. So pick 3 points that are non-collinear. Joey, can you give me the name of your plane?
Plane
F, E, G. Okay, does that work? Do we agree? And that's a good, I like that we said F, E, G. Do we agree or disagree with that? Can we name it plane F, E, G? Could we name it that? Someone else said they put E, F, G. Nod yes or no. Is this good or bad? Okay, I see some people saying no.
Wait, it can't be on the same line.
Good. It has to be non-collinear points. So again, we learn from our mistakes. I make mistakes. We're all gonna make mistakes until we get there. So that is a super common mistake that people would do because they're that's where your eyes go, right? Those 3 points. So they cannot be collinear when we're naming a plane. So I'm gonna use F and E, but what's the only other point I can use? I. Very good. Plane 5, okay. Okay, so that seemed like a lot of people also made that mistake too. Okay, C and D, I would like you to do with your partner real fast. We'll give you 30 seconds.
Collinear. It's not on the flat surface. The way it is.
Wait, no, it's not.
Bro, okay, I really do things.
Okay, 10 seconds.
Yeah, same. You know what? I don't get it.
Alright, track the board, please. The last one is debatable, or they're not debatable, but there's probably going to be a debate about our answer for that one. But C, it said, are points D and E collinear or coplanar? What did we put there?
Coplanar.
Okay, I heard both. Raise your hand if you put collinear. Raise your hand if you think coplanar. Okay, what does collinear mean? On the same
Line.
line, what does coplanar mean?
Same plane.
Same plane. So looking at D and E, are those on the same plane? Are they on the same parallelogram or quadrilateral? They're not, right? So they're non-coplanar, but do we see that they're both on line L?
Yes.
Yeah, so this should have been collinear. I'm just going to circle that. And the last one says, how many times do my planes P and Q intersect? Who put 2 times? Who put 1 time? Who put 0 times? Okay, so 0 and 1 were kind of like the debate there. If my 2 planes are intersecting, it should look something like this. Right? These planes are crossing through each other. Is that what my image looks like?
No.
No, these are what type of planes?
Parallel.
Parallel, which means they never
Intersect.
So your answer here should have been 0. Okay, I'm going to pause here. We do have, there is a back to that page. I told you today was long. We're not going to do the whole thing, but I'm going to pause here and ask you a question. Okay, so segment addition postulate. You'll see this word postulate. It's just another word for a rule that we follow in geometry. It tells me that if I have a line segment, so some endpoints there, I can add the 2 smaller pieces together. So I'm going to put smaller part plus my smaller part to get the whole line segment. So if I break it up into pieces, I can just add them together to get the whole thing. So it's not a difficult rule to follow. So if I were going to name my first part here, I'm going from where to where?
A to B.
A to B. Very good. So I can add AB, that's my first part. What would be the name of my second part there? Taylor? Taylor? B to C, very good. And then together it makes the whole segment, which is starting from where and ending where? Okay, I heard AC and ABC. How many points do we use for lines or line segments? 2. So we have to use our starting and ending point there. So make sure we're only using 2 points. So we're just adding pieces together there. Looking at our first one, that's way too easy for you guys because we know how to add at this point. So we're going to move down to C here. Okay, you'll hear me say this a lot. First thing we want to do in a problem in geometry is mark up the diagram or mark up your picture. So we're going to mark it up here. So it says EG is 71. I'm going to go ahead and bracket that. That's my small part or the whole thing? Whole thing. So that is 71. It gives me, straight on my diagram, what my 2 pieces are. And sorry, mine's blurry. You might want to look at your paper. So the segment addition tells me I can add the 2 smaller ones together and set it equal to the whole thing. So what is this equation going to be equal to? What is my whole thing? 71. So I'm going to go ahead and write equals 71 there. And I'm going to write mine off to the side. Okay, and what does it tell me to do with my 2 smaller pieces? Add them together. So I'm going to take exactly what I see. So my first part is 8x minus 17. And I'm going to add my second part, which is what? 5x minus 3. And that all equals 71. So we're just building ourselves an equation here. That's the only geometry to the problem. What's the rest of this problem? Algebra. So do we know how to do this? Yeah? What's my first step? Combining like terms. Let's go ahead and do that. So 8x and 5x. 13x. Then I have a negative 17 and a negative 3. When both of them are negative, what do?
You add them together.
And keep it
Same.
keep it negative. Good. So 17 and 3 is
Negative 20.
negative 20. Good. Okay, now I'm moving across, so what am I going to do here? Add 20 to each side. I get 13x equals 91. And my last step, divide it by 13.
Is that even?
It is a whole number. We don't have calculators, so we're going to do, you can do some long division if you want. I'm going to do a little guessing game here. So if I were gonna do, I'm just gonna pick 5 because it's always a good place to start. 5 times 3 would leave me with a what here? 5. We want a what? We want a 1, so that's not good. Let's say 6. What would that leave me with?
8.
An 8. Let's go higher.
7. Oh, 7.
What does that leave me with?
1.
Right? 21. And that would be 7 times 1, which is 7, plus 2 leaves me with 91. So x is equal to 7. So, good way to get unstuck there. But do we notice that the only geometry was the setup there? Everything else is just from Algebra 1. Okay, I'm just going to do that one example. We're going to move on to the last one and then be done. This one's easier to remember. Okay, so this is called the midpoint. If I asked you where I would find a midpoint, what would you logically tell me? In the middle. Okay, so if it is like the very center or the middle, think about what it is doing to a line segment. So if I have a line segment, AB, and I know that my midpoint is in the middle, what is it doing to that line segment? It's cutting it in half. Thank you. So that means that this piece is the same as this piece, right?
Yeah.
There's a new vocab word we're not going to write down, but you'll know this like so well by the, I don't know, like 2 weeks. Congruent is the same as equal in geometry. We just use that a lot of the time instead. So I would say that this piece AM, so line segment AM, is congruent. That's our little congruent symbol. If you can just write this down. This will make a lot more sense once we start doing some more stuff. But promise, that's going to be like the word that's ingrained into your brain. We use it so much. So we would say that AM is congruent. It's just an equal sign with a little squiggle on top. Congruent to MB. That just means that they are equal. They are the same. Okay, you'll notice I put these little dash marks on my diagram. That just means those are equal or congruent. So every time you see the word midpoint, think 2 congruent parts. 2 congruent parts. And I'm going to write that here. 2 congruent parts. Does that make sense? If it's splitting it in half, they're going to be the same. So that's just the definition of a midpoint. So in my first example here, it says Q is the midpoint. I'm going to stop right there. What can I already mark on my picture? What can I already mark? I'll give you a hint.
Oh, the congruent line.
The little congruent dashes. If you see the word midpoint, I know that is splitting this into 2 congruent parts. So please write that down. Okay, I'm really big on marking up pictures because that helps me to see if I'm walking around and I see those lines, I know exactly what you're thinking. I know that you're on the right track. So I know that these equal the same thing, right? They are equal to each other. They are equal to each other. So I want you and your partner to come up with an equation. So where would I put my equal sign in this equation to solve for x? If they are equal to each other.
In the middle.
Ooh. Yes, but you're supposed to do it with your partner.
Oh.
That's okay. So Bella kind of already helped us out. We're gonna put the we're gonna put the equal sign right in the middle. So I prefer these problems way more than the segment addition because there are less steps. So I know that those pieces are equal to each other. So I'll give you a second to solve, and then we'll be done for today. So please solve for x.
Shocking.